LinkedIn. All right. Hello, everybody. For the first minute or so, as everyone trickles in, I'm going to leave this up for you guys who are looking for jobs in open source or AI. Specifically, if you're looking for jobs in generative AI, this is a really good way for you to get connected with the right people. For the first minute or so, we're just going to leave this up, let people trickle in, and then we're going to get started. Mark and I are going to be talking about Gradient's 1 million, or actually, I think it's 4 million now, Llama 3 fine tune. So I'm going to go quickly announce this on LinkedIn, and then we're going to get back. All right, guys. So it's been about a minute. I see that there's a few people who are watching the stream. So if you'd like, we'd love to know where you guys are from. But for now, I'm just going to start. We're going to start with the podcast. So, Mark, I think the first thing that would be good to get started with is just an introduction of you. Who are you? Tell us about yourself.
Sure, Eugen. I'm Mark. I'm one of the co-founders of Gradient. I serve as the chief architect. So mostly what I oversee are the R&D aspects of our company. I spent half my career in quantitative finance and systematic trading, and the latter half of my career has all been in the tech industry within machine learning. Most recently, I was at Splunk doing streaming analytics as well as deep learning. Yeah, I live in the Bay Area, calling out from Burlingame. Actually, that's where our office is. So not in SF. Real close to the airport though, so it makes it easy to get coffee with any folks who are coming into town.
Oh, nice. Okay. Where is that from the airport? Is that like a little bit north, a little bit south? I've never been there.
It's about 10 minutes away. San Mateo is like the more major city that people know about, but yeah, it's like probably from our office, I can get on a flight within 10 minutes or less.
Okay. Yeah, I know San Mateo. Okay. Cool. I think I think this is a good segue into talking about Gradient, which is the company that you started. So tell us a little bit about Gradient. What is Gradient?
Yeah, so Gradient is a full stack AI enterprise platform for building autonomous assistants and agents. What we offer are all the primitives to be able to achieve that in like an end-to-end manner. And we're really targeted to enable business level production applications to be automated through like agent like workflows.
Cool. And so, what gave you the idea to start Gradient? Why did you start this company?
Yeah, I think I've always spent all my career in building machine learning systems. When I started out, I was doing it at hedge funds and trying to automate trading strategies. So adding the value there was incorporating the entire pipeline to be able to understand and run and add value. But it became readily apparent, both between myself and my co-founder Chris, who's at Netflix, that a lot of the common patterns we see across all organizations are that the fact that you really needed the AI to be powerful enough to drive value and actually be even better as the intelligence got better. So as we saw the rise of GPT-3, even before that GPT-2, we really just thought it was time to build a company that is betting on these models getting order of magnitude better within the next few years, which it's already happened. So now I'm looking for 2 orders of magnitude better in the next 5 years.
That makes sense. Okay, so I went on Gradient's website and I saw that you guys provide a variety of different services and products. So I saw like fine tuning, RAG, agents. Like, can you tell us a little bit more about kind of like how these work and what you guys are doing around these, let's say, frameworks or tools?
Yeah, I think the inception of what we built was thinking about um the real vision of AI, which isn't so much like, yes, you have chat interfaces and you have no code workflows and stuff like that, but um, we had to build something from the ground up with respect to like having the intelligence in the language models being better. So that's why, one part of about it in creating a secure production level platform for like enterprises is being able to host the models for one, like open source models, as well as providing access to the closed source models, and also having like specific models for tasks that can be called as functions. So a lot of people think about function calling in terms of APIs. I think about it more agnostically as like the language model is the brain,
Okay.
and it's like in a application and software application that we're building, like it's more like rather than being like a humanoid or a robot, it needs to interface with its environment, which is effectively all of the software and the APIs that exist uh, that is allowed to use. So then, what does that actually mean? You need an ability to fine tune the model to enable it to have specific behaviors. It gets a little bit more restrained and less general, but that's what you want for that use case. And then you also need like RAG and retrieval augmented generation, because you need to index that knowledge that you want it to be able to access at query time. And then to a certain extent, as my team develops better and better models like the long context model, like we can offer them before anybody else, or even do it specifically for some of our customers.
Okay. So I think one of the things I wanted to dive into real quick here was you mentioned that you guys have the ability to kind of host the open source and the closed source models, as well as like hosting these other tools for enterprises. What are you guys doing for that? Are you guys like are you guys kind of like providing a framework that they then bring the tools and you deploy into their VPC? Or is this something where you are providing the tools and the framework and deploying into their VPC?
Yeah, I think it's a little bit of a la carte on both sides.
Okay.
So like depending on what the needs are for the company that we're working for. So like we have we operate a lot in the finance and the healthcare sector. With respect to healthcare companies, some of them won't even um they're not even going to consider closed managed models. So
Yeah.
then in that case, like we deploy into their VPC. And in other cases, you have like some early mid-market startups that we'll work for, and they're okay with us managing their GPUs because one, what they care about is the product experience and the latency and the throughput of their applications. So then we have the GPUs available for them to be able to work with the model, and it's similar to just calling an API and being charged for that service that way. Um, and some of the tooling behind all of it is like, yeah, we're not going to reinvent the wheel. I think there's so much amazing tooling that's evolving over time, right? And having one company focus on that, like, but we focus on bringing it all together into like the compound AI system.
Okay. Yeah. So that's really cool. What you guys are doing is definitely going to be something that's a critical part of the future of these kinds of generative AI applications. So I think now would be a good time to kind of dive into the title of this episode, which is about the 1 million context window fine tune that you guys did for Llama 3. So why did you guys build this long context extension for Llama 3?
I think it was a no-brainer for us. One, we're always tinkering with new models as they come out, really evaluating them and figuring out like what are their capabilities, because to a certain extent, like we're guiding our customers there too as well. Like a lot of enterprises, they lean on us to be able to help them determine what their needs and their roadmap is going to be. But beyond that, the number one criticism coming out of the Llama 3 model was the 8K context length, because that's actually kind of short in today's day and age. And it's sort of table stakes for models to go to like 16,000 or 32,000 these days, because of the like, think about retrieval augmented generation to a certain extent, right? Like if you have, in a lot of cases, we have like these long system prompts that helps guide the model and provides really instruction following capabilities. And stuffing in more context becomes really hard when it's that small, right? So we just shot for the moon, and we thought it's time to just go. Gemini said they had 1 million. Let's see if we hit 1 million for the open source out there.
Yeah, I mean that makes sense. So quick question here: why Llama 3? Are there any other open source models that you guys are looking to fine tune to extend the context window for?
Yeah, definitely. I think it's an interesting relationship because Llama 3, again, like I said, is a no-brainer. Everybody's been waiting for it.
Yeah.
And the other thing about models, I think, which people some people understand, some people don't, but like a lot of it is just the community trust in the brand.
Mm.
So to a certain extent, I'll call it a few models that I actually think are excellent, but aren't as adopted in the community. So one of them, some of the stable diffusion models like stable LM, they even released a really great technical paper about it. Fantastic small model, but it wasn't getting as much adoption as maybe like the Mistral models.
Hmm.
The other set of models is like the DeepSeek models coming out of labs in China. Those are the same as well. And in a way, it's almost like programming languages. Like you want to go towards where the community gravity is for these models, because people are also exploring them, augmenting them, customizing them, and you're able to actually learn a lot from that. So going into Llama 3 was an obvious choice to us. And also the fact that like the amount of tokens sent through that model gave us a lot of suspicion that it's going to have way more knowledge and a much stronger world model for us to be able to work on.
Okay. Oh, that's really interesting. I hadn't really thought too much about the community adoption for the branding, but I mean, a lot of it makes sense. That's probably why Mistral is so well adopted, is because they have that branding to them as well. So one of the things that you mentioned is that you guys chose to fine tune Llama 3 because it has only a context window of 8,000, whereas some of the new models coming out have 16, 32,000, even Gemini with 1.5 million. What makes fine tuning something for a long context window so hard?
Well, I think this is sort of like beating a dead horse, but to a certain extent, same thing that Sam Altman says all the time too, as well, right? Like the number one blocker for a lot of progress in AI is actually scale and therefore compute. So with a long context model, there's not really a way of getting around during the training process of having to have a lot of VRAM and GPUs. But once you get past that, we had a great GPU sponsor for this project. Shout out to Crusoe. They provided us an awesome cluster of L40Ss, and we jumped on the opportunity to really utilize them. But outside of that, it's a lot of setting up the distributed training strategy. So that's the other aspect. And then finally, it's about curating the right data set for the model to have the best sample efficiency for learning. And we were lucky too. Like the community has been working on that. There was already a repo that was called Easy Context that provided a head start for us on that. And then for us, we migrated that repo and extended it for the specific network topology of the cluster that we were working on. So then we were able to get in and quickly just extend that context length. And I think the community got excited. It was almost like every day we were launching a new model and seeing a lot of people try it out and adopt it.
Yeah. So I want to go into like two things here. So one, So you talk a little bit about the one of the barriers, or one of the difficulties here is that you have to be able to um, create a way to train these distributed in a distributed manner. So I'd like to kind of like get an idea from you about, how did you guys do that, and what kind of topology did you use? Like, what were your strategies for approaching that? And then
Mhm.
the other thing is, did you have to change that as you decided to train from the 1 million to the 4 million?
Yeah, from that standpoint, we were uh we had planned, like, you always come in to everything with a specific plan, and then you work on your experiments, and you see what happens. I think I would definitely say, like, as we got to the 1 million, the 4 million, that started to push the limits of how we set up our network topology. And maybe I'll dive a little bit more into the specifics of, like, the distributed trading strategy. So, like, the main components of that was, one, you should probably be using flash attention, because that buffers the attention that you have to keep in memory. So it turns it from quadratic to linear scaling. And then secondly, we also use ring attention. So ring attention, what that does is it kind of, if you view it as a round robining the attention mechanism across the entire set of virtual machines that you have. You're basically doing that type of network communication, and rather than having to hold everything in one virtual machine, or having to have all of them have all the attention at the same time, like, you're actually round robining it. Now that comes with its own set of requirements and constraints. So uh, oftentimes when you're doing distributed training, and you're starting to push the boundaries of how much VRAM you have, the communication, the network becomes the bottleneck. So in that fashion, we actually had to come up with a very specific way of the set of virtual machines talking to each other while they trained. So instead of going all the way this way, we actually had to break them up into, different ones talking to each other, and then communicating all around in, like, a interesting gather step. So having all that come together is like, hey, you just have to experiment. You have to run your metrics. You have to be tracking all of these things, and then finally, you have to make sure the thing's learning, because, like, at the end of the day, machine learning is about learning. We're tracking the perplexity curves during that time, and all at the same time, we're sort of like, hey, we got to keep up the momentum, because it kind of feels like tons of people are getting interested in this, and that's why we kind of kept going, and eventually that's why last week we released the 4 million context length model, which we're still working on. We were very transparent as it being something that will continue to progress, and put at the level of the other models too.
Okay. Oh, I've never heard of ring attention. This is my first time hearing about ring attention. Flash attention, I'd read the paper on. Ring attention is interesting that you've changed the bottleneck from the RAM that you have into the network. So that's a very interesting kind of like switch there that allows you to kind of do more training, but with a different challenge or restriction. So one other thing I wanted to ask about is, I think I read somewhere that this was fine tuned for chat. And I wanted to also like learn a little bit more about this kind of difference between fine tuning for chat versus fine tuning for like function calling, or some other or some other sort of functionality.
Yeah. So to be clear, you kind of have to do both. So
Okay.
just like regular models are, uh, you can do continual pre-training on them to inject a little bit of knowledge. We did do effectively a curriculum learning style training, and the two data sets that we used for that were the Slim Pajamas and Ultra Chat. Different variations of it have come out online, but either way, like, what it really is composing longer sequences of conversation, and, like, the multi-turn aspects of conversation, to embody the chat data set and the samples. to allow your model to actually understand, like, hey, it's almost like when you have whenever you talk to ChatGPT, it remembering different aspects of what you talked about in the beginning of the session and actually correlating it to what your current context is. And at the end of the day, I'll take something out of attention, but it's all about figuring out how you can make your model attend to different localized positions inside of an entire sequence. So if I am at index 20,000, attention is, well, at least the original self attention was just, a vector multiplied by itself, and then looking back at different parts of your context when you're at a specific step. So I think about when you train these models for longer contexts as like, how can you take the different permutations of like locations to encompass concepts that you want to communicate to a model.
Okay. Oh wow. So I guess like so either way, the way that you think about fine tuning this is not really so much about fine tuning it for a specific type of functionality, but rather how different, let's say, uses or functionalities have to do with like the where the model has to pay attention to in its context.
Yeah, maybe I skipped over a little bit of the function calling aspect. So I think the content itself is also important to, for those that have not fine-tuned any models for function calling. A lot of it is like representing. It's almost like representing an API. So like you can have a spec for the API. Oftentimes that is a JSON spec, and it's JSON. To be clear, it's JSON because all of the data that's been passing through these models and all of the web crawls and all of that, they've been learned. So the model is just much more attuned to learning that. More recently, a lot of people have been looking at like YAML to be able to represent what a function spec is. So it's almost like if you were to want to create a web app and you go onto like Twilio and you read the APIs, like you don't actually know what the code is behind the scene. You only know like what you're getting back and then what is the function signature you give it. So you train on that, and then you actually train on like, hey, this is the input going into this function. Here's an example of the output. And you can do that in multiple different variations. And then what would be interesting is effectively like an extended function calling example, right? Like you give a function in the beginning, and then you have other functions that the model already knows, and then you could chain like a pipeline and then give it many examples of like what the output would look like to get the model to really learn the function really well. So I think the interplay between, the extend, that's why we wanted to extend the context length to prove to ourselves and prove to the community that like you can use this and it will impact all downstream use cases for language models.
Okay, yeah, that is really interesting. The relation of function calling to APIs makes a lot of sense to me. So you guys are focused on kind of providing solutions for the enterprise use case, and so what would be interesting to know is what are some common use cases for long context windows, and specifically as it relates to enterprises.
I think this is something we think about all the time, and we're still doing more and more evaluations to find out undiscovered use cases. I think to start out with, since we're talking about function calling and coding, if you ever worked with GitHub Copilot, it feels like it's more of an autocomplete than it is like a true coding assistant, right? I think that's what all the hype around Devin was it just felt like very autonomous. With respect to how you would use long context, a lot of the times I find myself that the code completion suggestions or the code suggestions that are coming out with some of these copilots feel a little bit stuck because it doesn't understand why one piece of my module, my context, relates to the rest of the entire project or the repository, right? So imagine if you could drop in an entire repo into the context of model and then ask it to produce code for you. Like ask it to produce the unit tests that are necessary, the CI, the module itself. Like that takes a lot of knowledge, and obviously the model itself needs to be smart enough in terms of its reasoning capabilities. But like that's just one example for coding. And then hey, there's other examples like legal. So when you're analyzing or doing like legal analysis for like a specific case, oftentimes you want to be able to refer to previous precedent. So having to take all the previous precedent and making a model create this network of logic behind, hey, because of X, Y, Z precedents, you can see the evolution in the law. And therefore, in this case, these are the recommendations or the summarization that I would have in place. And we know that lawyers are paid by the hour. So it's kind of something like you're going to see a lot of text come into these corpuses and in the context of the model. So long context plays a huge role in those, and we have not even truly begun to scratch the surface for those use cases either.
Yeah, that makes a lot of sense. We have a question from the audience that I think we can just take now. So I think this person might have came in a little bit late since we had talked about the second part already. But why does Meta not come out with a long context window for their own models? And maybe we can briefly recover how your long context was done at Gradient.
Yeah, I you'd have to ask Meta themselves why they didn't start off with releasing that. I'd say like from a practical standpoint, right? Having to train a long context model is much more expensive. It might be more sample efficient to first train for the shorter context. Like you can always keep on adding longer context extensions. There's been numerous papers out there, one coming from Meta, that actually showed that if you train solely on the long context, it's actually less sample efficient than training on shorter contexts and then extending the context at the end of training. And that's because you got to think about it. Whenever I think about all these models and training them, I actually think about a human being. So like as me and a human being, I don't start off with trying to understand an entire book by reading the book cover to cover and doing no exercises. What you want to do is you break out your modules and you learn the concepts and they build on each other, where finally you can add like an extremely long context to reason over. And that actually works with higher fidelity and higher quality than training throughout the entire training process there. So we don't know. Maybe they will release a longer context model. Maybe we inspired them to do that a little bit faster. That'd be really cool. But we're up to working with them too as well on evaluating them and working together collectively to just make it better for the community.
I mean, that's really interesting. I didn't realize I hadn't read that paper, so I didn't realize that they had said something about like the difference between training long context and starting with short context. So I think you briefly touched on this, but what do you see happening in the landscape of generative AI over the next, let's say, year, 2 years, or 3 years?
Oh, I mean, that's a VC question. But to be honest, like, what I see is one thing is everybody's sort of obsessed with the speed of inference in trying to get it down, to maybe even like to that of effectively traditional search, right? Like 5 milliseconds for like really long context and stuff in different matters like that. And I do think, hey, to a certain extent, I do believe in Moore's law where infrastructure and hardware starts to get better and the speed of the chips the technology is only gonna get better on that side. But on the opposite end, what we're really thinking about in terms of the vision of AI and what we really think that people will be surprised about is, can you make your autonomous assistant do a task, break it down, go away for 2 days, and then come back with an answer at the level of a human being, like a a very elite level human being in that, or knowledge worker in that task, like what kind of experience will that be, and what do people expect out of it? Because
That's
like,
wild.
yeah, exactly. Like if I had a bunch of, if I had, these days, like we have our Asana board, and we do our planning. We have tickets, and uh uh for like, and then what if you could just send off your swarm of software agents to close tickets in 2 days, and they come back to you at the same quality as any other software engineer out there? I think that will you really be complaining about, hey, this thing is not coming, it's not streaming the tokens as it's doing it, right? Like, does anybody have time to look at that as an engineering manager? I don't think so. So I think that's where the other paradigm that we haven't quite seen come out, and a lot of startups, enterprises are working on it. But the long-term planning aspects of language models, as they get better and they get better at reasoning, like I think that'll start to emerge a lot more, and people start talking about that.
Yeah. Okay. That's really interesting. I think that's a very different view than what a lot of people have been saying. We've got another question from the audience. Do you do needle in the haystack testing as you go? I think this is in reference to how you're training your model for a longer context window.
Yeah, I mean, we have to do that. I think to a certain extent, we see needle in the haystack as like a primitive that you have to get right. Otherwise, your model isn't really great at looking up, or it's very close to the original test that even before needle haystack that Greg came up with, was the pass key retrieval evaluation. And it's just like following along and being able to attend to the right context within like a huge, basically an ocean of random stuff, and like trying to find that specific key value pair. So if you can't get that right, you're really not going to have great instruction following capabilities on 1 million contexts. So to extend the context from 262 that we had to our 500 K context length model, we had to make sure we got to 262 right.
Okay. So I'm going to ask a follow-up question to this. How do you do the needle in the haystack testing? How does that work?
I think the two aspects about it is needle in the haystack. How that works is you have your needle is effectively like a value, and then you have a question associated with that, and you basically say, hey, what is this? Like the key is this number, like it's a numerical number. It could be a word too as well, but from our standpoint, we just took the original evaluation itself, and then you throw that key value into a bunch of text. We've seen two different ways of doing it. Some people just take maybe a couple sentences, and then they replicate that sentence across the entire context. So then it's really just a bunch of like repeated sentences all across it, and then you hide the key value up front and ask the language model, hey, what was the value of this inside of this context? And it's supposed to give you the exact value out at the end, and it's like an exact match. We had a post that basically said like a lot of stuff with respect to that. Like you have to make sure you have to make sure what your haystack looks like. So repeating the same sentence over and over is actually a lot easier than in our case, when we actually we extended that evaluation, we threw all of War and Peace, because that was the longest book I've ever heard of. And like I remembered how long it was, and it's approximately 500,000 words. So then converting into tokens, you get like if you use a heuristic of like 1.4 times the 500,000, I think you probably get like 600 something to 700,000 tokens in there. So then that's like natural language, varied sentences. So there isn't as much like repeatability within there, and that actually becomes a little bit harder in the evaluation. So finding that is also difficult. And Friday we also released a bunch of results from evaluating the ruler benchmark. So that's like a suite of different benchmarks that are much harder than needle in the haystack. where you're finding like multiple needles, finding multiple values, and also finding like tracking variable changes, like x equals y equals z. So what was z setups, and that provides like much more interesting uh, understanding of what's actually going on there.
Wow. Okay, that's pretty cool. That sounds like a much more robust test as well. So, what's next for you guys? What's next for what you guys have on the horizon?
Yeah, I mean, we're not trying to be the people that just keep on throwing out long models to a certain extent. Like we want to have a good reason for it.
Yeah.
So we're heads down doing evaluations right now, and also figuring out how we can improve the models. Secondarily, we've just had so much interest with respect to these models that we're gonna host it, and we have a wait list that it's gotten really long at this point, for people wanting access to them. And then what we are as a company, right, our identity is building the autonomous agents and assistants for enterprise. So we're going to be improving like the planning and reasoning capabilities and identifying like the opinionated workflows that will add the most value to our customers. So being able to compose out, we think that long context will have a lot of implications for opening up way different use cases out there in companies. So combining that, like looking at some of the workflows in production that we've helped some companies build, and saying, can you replace certain parts with just one model call? Like, are the reasoning capabilities good enough so that it simplifies the workflow, or maybe even being blocked on certain other workflows and certain other automations that could have been possible if we just had a model that's long enough. So I think everybody's really excited to get their hands on them, and we're just going to continue to try to support that demand, and also like I said a few times, work in the community. Like I want to know what other people are working on, how you guys are thinking about evaluating these models. From my standpoint and my viewpoint, it's a lot of greenfield. So people are still trying to determine how to actually evaluate them when you have like 1 million tokens, right? Like it was already controversial when it was only like 2,000 tokens, but these days with 1 million tokens, I think it's just, all up in airs with respect to getting agreement and consensus about like, did the model actually get better? Did it get worse? All of those type of aspects.
Yeah. So I think this kind of wraps up a lot of our technical questions. I'm about to get into the lightning round. We're going to ask you some just some different questions, and I'd also like to let the audience know this would be a good time to start thinking about what kind of question you guys have for Mark, and to drop them into the chat. But before we have the audience ask their questions, or as you guys are thinking of your questions, Mark, what is one question that if you could ask the audience, what would you ask?
Yeah, I mean, for the audience, I'd say, what's the most interesting use case that you guys can't do because you just can't fit enough context into your models right now? Like if tomorrow you got a model that had the ability to take in 500,000, 1 million context, what would you do with it? Because I think that's what I'm most interested in building. It's kind of a build it and they will come. Now I want to know what you guys want to use it for.
That makes sense. Okay, so let's get into this. What is one place that you recommend everyone visits?
Interesting question. One of my favorite cities in Italy is Bologna. I think there's a lot of different shows that have kind of been on Netflix about it, but it's awesome city. To me, it's like you get Rome, but you get more like it's in between Rome and Tuscany, and an amazing place to visit. And I went there 2 years ago. It's really good food, and I can get into deep thought there too as well because it's not too busy. So it's a great place to visit.
Cool. I've never been to Bologna. I've actually haven't been to Italy, so I'll have to add this to my list. What
Yeah,
is
you can use GPT 4o. It seems to be pretty good at Italian, so you can get around.
Okay, well, I think this we can add this. This is one of the questions on my docket. So, what do you have to say about GPT 4o?
I think it's interesting. I mean, it's something that we were thinking about too as well. The O stands for omni, so it's the fact that it's truly a multimodal model, which also implies possibly that GPT-4 vision was not natively multimodal. So I think that's kind of interesting too as well. But it's pretty seamless as an experience. I think it's still TBD. They didn't announce much or talk much about it. But something that's clear to me is like the model's a lot faster. So it's faster either due to an architectural change, which maybe they have some sort of algorithmic state of the art innovation on that side, or it's because it's more sample efficient. So like the model, or sorry, not sample efficient, but it's more efficient because the model maybe is just as fast or is faster because it has less parameters, and because of the effect of having multiple modalities and having a better way of teaching it those modalities together, you now have like a model that can run at higher speeds, lower latency, and also work across all of the different modalities a lot better and seamlessly. So yeah, I'm looking forward to, I heard Apple's trying to license it. So Siri kind of sucks in comparison to GPT 4o now. So hey, I want it on my phone. I want to be using it rather than Siri.
Yeah, fair enough. What is one paper that you recommend that everybody reads?
So I actually recommend two things.
Okay.
Which is funny because you get these, they relate to each other. So I'll kind of preface it first. The first thing I think everybody should read is The Bitter Lesson by Richard Sutton. So the thing about that, like that probably inspired and is quoted and alluded to by a lot of researchers. I didn't really understand it until I started reading it, or I read it a few years back. But what it basically says is you can think about all these analytical solutions, and you can think about how creating like a really specific algorithmic innovation for something, but you also need to position yourself and position your research and development in the directionality that technology will get better. So like that's why search and monty tree based methods have gotten so good at uh, for AI, is because like the chips have gotten better. Like we can have more data, GPUs have gotten better, and therefore like the techniques to a certain extent won't matter as much. Now the specific paper I think everybody should read is actually the original scaling law paper from OpenAI, because it's an amazing paper. They did so many ablations with respect to changing model architectures and changing all of the inputs to the models, and then effectively showing that when you scale up, that's the only thing that matters. Like you just need throw more flops at the problem, and you can actually target downstream use cases, and you can hit different the loss curves are very predictable with respect to how good the model gets and the performance gets. So that's something I keep in mind all the time, because hey, how do we as a startup survive when to a certain extent that compute and scaling is the thing that will differentiate or that will progress these models. So you got to have to be like, yeah, we target our use cases and we really targeted about what are the experiences and value that we add, knowing that the capabilities of AI are only going to get better, and needing to be able to just adopt it when that does happen, right? Like how many people said day zero support for GPT, like that was tons of companies said that, and having that nimbleness, I think, is actually going to be integral to like your success.
Okay. Yeah. I mean, that makes a lot of sense. I haven't read the Bitter Lesson, but I guess I should go read it.
It is a bitter lesson. I'll tell you that much.
Better to read it from someone else than to learn it. So I think your answer by the scaling law might have answered this question, but just in case it didn't, what is your favorite machine learning concept?
Oh, interesting. There are so many. I do think actually, this is funny because this is not really machine learning. Statistical learning and machine learning have their own intersections and stuff.
Okay.
But like, I have a statistics background. What I do think, everybody probably knows this theorem, but taking a look at it, it's almost like the scaling law to a certain extent of like how incredibly simple, elegant, and powerful it is like the central limit theorem.
Okay.
Like it's really weird because the central limit theorem basically governs like all these processes we have, and the fact that if you just take the sum of normalized processes and then you scale it by the square root of its you scale it by the square root of the number of observations, it like standard deviation, like you approach a normal distribution. Like that doesn't really make a lot of sense to me, no matter what you have with respect to that data generating process. It just goes to normal. So that's also kind of like, I see the analogies to like the scaling laws for models too. And speaking from a point of like a researcher too as well, it's these type of properties and these type of empirical laws that you see that excite me the most, because they're just like so elegant, and they kind of simplify the problem space that you work in to a certain extent. Because like, I think at all times you have like 10 things that you just don't know the answer to, and having the intuition and like, can you ground yourself in one law and just scale it up? I think that's kind of impressive.
Yeah. Okay. So I think the audience has asked all the questions they want to ask during the talk, I guess. And there's one more question from me, which is, how do we get access to this Llama 3 model that you guys have?
Yeah, we have an intake form, Google form for our waitlist currently. Bear with us. It's not an easy problem. This is why there aren't that many 1 million context length problems, and we're just a small, we're a scrappy team at a startup. But we're gonna get support for that. We're gonna host a model for folks to be able to use on our APIs. And yeah, just sign up on our Google Forms. I can share the link after the StreamYard, or on LinkedIn. We can share it out to everybody, and just put your name down. We're really looking for use cases. So like, the more descriptive or the more relevant the use case is, like the sooner we'll have access to the API.
Yeah. So please send me that link, and I'll send it out to everyone via email afterwards. I think this concludes our presentation for today. Thanks for taking this time to come and talk to us about the 1 million context window fine tune that you guys did for Llama 3, and how you guys did that, Mark.
Yeah, thanks. It was great sharing with the community. Follow us at _gradient_AI on Twitter, as well as gradient.ai is our website. And you can follow along me, but I'm a lot less interesting than the stuff that we post out on our website.
Cool. All right. See you, everyone.
Cool. See you.